So today we get to answer a really interesting question on ionizing radiation with photons. So let's look at the question. So when there's an energy transition in the nucleus and a gamma photon is produced, is that similar to bremsstrahlung radiation, or are the mechanisms different there? Great question, and the mechanisms are different. Now, bremsstrahlung radiation is largely what we get from X-rays. If you have had a medical X-ray, most of that radiation was bremsstrahlung. Now, a formal X-ray occurs when you have, say, a heavy metal like tungsten, and you excite one of the inner shell electrons near the nucleus up to the outer shell or near the outer shell. And if an electron in that outer shell transitions down, there's a large energy difference there, and that's given off as a large energy photon. And we call that an X-ray as opposed to visible light, which is a smaller energy transition of those orbital electrons. Now, as this person asked, if you do the same kind of physics in the nucleus, where one nucleon is excited to a higher energy level by some means, and when it comes back down and it gives off radiation, the photons that come off from that we call gamma. And you get energy transitions in the nucleus or in the orbiting electrons, and generally the energy difference in the nucleus is much higher, so gamma radiation generally is much higher than with X-rays. But bremsstrahlung, that's actually German for breaking radiation, and that occurs when the electrons that are accelerated in an X-ray machine, it's actually an electron accelerator in there, it accelerates electrons into usually a tungsten target. And those electrons, they might be a few hundred keV, something along those lines in terms of energy. When they knock those inner shell electrons up to higher energy levels, those will create the traditional X-rays. But most of the radiation is bremsstrahlung, and that comes from slowing down the electrons, breaking them. An acceleration in the negative direction is what gives off the bremsstrahlung. And that's from Maxwell's equations, that conservation of energy, the energy of that electron as it's slowing down, because there's an acceleration on it, that's going to create electromagnetic energy. That electromagnetic energy has a spectrum, and that spectrum is what we call bremsstrahlung. So bremsstrahlung is breaking radiation. It's from the deceleration of electrons. You can also get it with other charged particles, but that's usually where we find it in society today, is in an X-ray machine. So thanks for the question. Keep them coming. I hope you enjoyed the video and learned something, and that you have a very nice day.